Our warm greetings to you, ma'am. The topic for our presentation is eco friendly alternatives to petrochemical plastics.
Introduction. Introduction. Plastic is a synthetic material made from a wide range of organic polymers such as ethylene, PVC, nylon, etc. Plastics are used in household packaging material, in bottles, cell phones, etc. These plastics are derived from petroleum and natural gas, so it can cause pollution.
Let's talk about the environmental impact of plastic. Plastic pollution is having a significant environmental impact. Plastic pollutes ocean and beaches. Plastic wastes dumped in water courses contaminate and poisons freshwater life. Plastic reduces soil fertility by forming the part of manure for years.
Now let's discuss the effects of plastic on animals. Plastic plays the villain right from the stage of its production. The majority chemicals that go into the making of plastic are highly toxic and pose serious threat to living beings of all species on earth. Plastic bag kills animals. Many animals ingest plastic bag mistaking them for food and therefore die.
What is bioplastic? Bioplastics are a form of plastic derived from renewable biomass source such as vegetable oil, cornstarch, potato starch, rather than fossil fuel plastics which are derived from petroleum. Bioplastics are biodegradable, meaning that the material returns to its natural state when buried in the ground. Bioplastics are degradable polymers that are naturally degraded by the action of microorganisms such as bacteria, fungi, and algae.
Why bioplastics? India is the third largest consumer of plastic. Plastics are predominantly produced from crude oil. Hence, renewable sources are becoming more viable and promising alternative for plastic industry. When plastics made from petroleum is burnt, they release carbon dioxide contained in petroleum into the atmosphere, leading to global warming, and it is not degradable, which is not a problem with bioplastics.
Let's talk about the composition of bioplastics. Bioplastics can be made from many different sources and materials, which include plant oil, cellulose, cornstarch, potato starch, sugarcane.
Now we will discuss about different types of bioplastics. Polyhydroxyl alkanoates PHA, polyhydroxyl butyrate PHB, polylactic acid PLA, starch based plastic, cellulose based plastic, protein based plastic.
What is cellulose? Cellulose is the most abundantly occurring natural polymer on earth. Cellulose is a very inexpensive natural resource. It is comprised by glucose monomer units that are joined together via beta 1,4 glycosidic linkages, which enable cellulose chains to pack tightly together and form strong interchain hydrogen bonds. It is soluble in hydrogen bond breaking solvents such as N-methylmorpholine N oxide. It is, however, difficult to use in packaging because of its hydrophilic nature, poor solubility characteristics, and highly crystalline structure.
Polyhydroxyl alkanoates PHA. Polyhydroxyl alkanoates are linear polyester produced in nature by bacterial fermentation of sugar or starch. They are produced by bacteria to store carbon and energy. PHA are more ductile and less elastic than other plastic. It is also biodegradable. These plastics are being widely used in medical industry.
Let's talk about starch. Starch, which is composed of amylose 20 to 30% and amylopectin 70 to 80%, is primarily derived from cereal grains like corn. Other commonly used sources of starch are wheat, potato, and rice. Starch is the major carbohydrate reverse in plant tubers and seed endosperm, where it is found as granules. Its application in biodegradable plastics is either physically mixed with its native granules or melted and blended on a molecular level with the appropriate polymer. Amylose is responsible for the film forming capacity of starch. Starch based films exhibit physical characteristics similar to plastic films in that they are odorless, tasteless, colorless, non toxic.
Polyhydroxyl butyrate (PHB). The polymer poly 3 hydroxy butyrate (PHB) is a polyester produced by certain bacteria processing glucose cornstarch. Its characteristics are similar to those of petroplastic polypropylene. The three most unique property: first, 100% resistance to water; second, 100% biodegradability; third, tolerate heat above 170 degrees Celsius. It's widely used in industries, biomedical agriculture feed.
Our next topic is polylactic acid PLA plastics. PLA is emerging as one of the most attractive packing material because of its excellent biodegradability, processability and biocompatibility. Polylactic PLA is a transparent plastic produced from corn carbohydrate. Its characteristics are similar to conventional petrochemical based mass plastics. PLA is mainly composed of lactic acid. Lactic acid is mainly produced by bacterial fermentation of carbohydrates. It is used in the plastic processing industry for the protection of films, fibers, plastic containers, cups, and bottles. PLA is the most environmental friendly bioplastic available.
This figure shows the flow chart for the production of PLA.
Let's talk about how the synthesis of PLA is done. The synthesis of PLA is a multi step process which starts from the production of lactic acid and ends with its polymerization. Lactic acid can be obtained from renewable sources like corn, potato, sugarcane through fermentation. An intermediate step is often the formation of the lactide. The main process is ring opening polymerization, which is also known as ROP, of lactide to obtain high molecular weight PLA.
This figure shows the synthesis of PLA.
Now let's talk about the comparison between some common plastics and bioplastics. As you can see in this table, the polymer, which is cellulose, has high to medium moisture permeability, high oxygen permeability, and good mechanical properties. Cellulose acetate has moderate moisture permeability, high oxygen permeability, moderate mechanical properties. Starch have high moisture permeability, low oxygen permeability, and good mechanical properties. Polylactate has moderate moisture permeability, high oxygen permeability, and good mechanical properties. Low density polyethylene has low moisture permeability, high oxygen permeability, and moderate mechanical properties. Polystyrene has high moisture permeability, high oxygen permeability, and poor to moderate mechanical properties.
Comparison between oil based plastic and bioplastic. Property renewable. Bioplastics, yes. Oil based plastic, partially no. Breakdown in the environment. Bioplastic, degradable and compostable. Oil based plastic, some degradable by polymer oxidation. GHG emulsion, bioplastic, usually low. Oil based plastic, relatively high. Fossil fuel usage, bioplastic, usually low. Oil based plastic, relatively high.
Uses of bioplastics. Number 1, reduced carbon dioxide emissions. Number 2, cheaper alternative. Number 3, bioplastics reduce the amount of toxic runoff generated by the oil based alternatives. Number 4, reduced carbon footprint. These carbon dioxide emissions are 4 times higher than the carbon dioxide emissions for polylactic acid. Number 5, beneficial to rural economy. Prices of crops such as maize have risen sharply in the wake of global interest in the production of biofuels and bioplastics.
Application of bioplastic. First, packaging. The use of bioplastic for shopping bag is already very common. After the initial use, they can be reused as bag for organic waste and then can be composted. Trays and containers for fruits, vegetables, eggs, and meat. Bottles for soft drinks and dairy products. Bistler foils for fruits and vegetables are also already widely manufactured from bioplastics.
Bioplastics are also used in catering products such as single use cold drink cups, plates, containers, and cutlery, which are all based on renewable raw materials and are compostable after use. Polylactic acid can replace PET in certain applications, biomedical field, paper coating by food industries, and lastly, sanitary products.
Now let's discuss some disadvantages of bioplastic. Bioplastics are made from plants such as corn and maize, so the land that could be used to grow food for the world is being used to grow plastic instead. If biodegradable plastic is not properly disposed of, it leads to an ineffective breakdown of the plastic, which can release toxins such as carbon dioxide and methane in the environment. Sales value, this range from cellulose and PLA being up to 50% more expensive to starch and PHA reaching up to 4 times the price of the conventional plastic. GHG emissions. Cellulose film currently have higher GHG emission than conventional PP film. Evaluate packaging.
These are some references which we used while making this presentation.
With this, we have come to the end of our presentation. We would like to thank you for giving us your precious time.